Welcome to 24th lecture, and we have now come to a very important situation where we are beginning to understand how the windings of a rotating electrical machines, AC machines will look like. And I was telling you that if you look at this example, suppose a machine is having 12 number of slots equispaced, and if you like you can calculate also beta, the angle between two consecutive slots, which will be 180 by 6, that is 30 degree electrical. Total number of slots 12, number of poles per number of slots per pole is 6. Therefore, a full pitch turned coil, if I want to use, I must and I have numbered the slots, and based on the slot numbers I will now slightly change the coil naming, coil side naming. Earlier I was telling 1 dash to identify a coil. Now, there is a slot, definite slot, in which a particular coil side will be present. So, I will be naming them after the name of these slots. For example, this front end of this coil I will call it 1, and this coil side is 1, I will refer to like this, and this one is returning to 7 slots because I want to use a full pitched coil. So, perhaps I can name it as 7. That is also, so it should not be understood as coil 7 I am talking about. Start of the coil is at slot number 1 and its finish is at 7, and this angle is 180 degree full pitched. This is one thing I would like to tell. Another thing I would like to tell, that, and you will see at the end all these slots should be filled up. So, that whole periphery is utilized with copper, that is conductors. Okay. So, better utilization, perhaps I will be using distributed windings, that is to be used in fact. Now, apart from this, there is another important thing, that is to utilize the slot space properly. What is done? Suppose this is slot number 1 and dot dot dot, this is suppose slot number 7, the same thing I have drawn, and what is this term is called double layer winding. We will be talking about. This is single layer. In each slot there will be only one coil side present. Therefore, each slot, when it accommodates a single coil side of a particular coil, it is called a single layer winding. As shown here, 1 7, one coil side, and this coil side of course is having multiple turns, multiple turn coil. But double layer winding, what is done is that in each slot, there will be two coil sides present, and two separate coil sides will be present. Of course, therefore, this is that is this slot, if you imagine, it will be having a upper deck and a lower deck. For example, if I want to make a double layer winding of this, I will place one here and its return I will place it here. Understood? This is how my winding will progress. So, 1 and this lower deck, upper deck 1 is one coil side of coil 17. If you use this double subscript now, its finish is at slot number 7 and it will be in the lower deck. In the upper deck and lower deck of slot 1 and 7, there will be other coils. Therefore, in a double layer winding, each slot there will be 2 coil sides present. Therefore, if I know the number of slots, total number of slots, how many total coils it can accommodate? How many total coils? Each coil requires 2 coil sides. Therefore, if double layer winding is being used for double layer winding I will write in short as WDG. For double layer winding, number of total slots, that is S is equal to S, will be equal to total number of coils. Since each coil requires 2 coil sides, therefore, how many total number of coils can be accommodated? Capital S. If it is a single layer winding, number of coils that can be accommodated is equal to the number of S by 2, is not S by 2. Therefore, so this will enhance our utilization of the windings. So, it will look like this diagram. If you look at, these are the slots, this is one coil, its start is at the above. I think in 3 dimension, if you look at this diagram, this is the starting coil side and its finish comes out from this below. So, this is the thing, is not? This coil, here it is, its return is here, you can physically see below this. Similarly, this coil, it is another separate coil, its return is from below. So, in each slot there is 2 coil sides as shown here, and when these other slots will be filled up, everything will have 2 coil sides, lower deck, upper deck. And these coil sides, obviously, the other coil side which will occupy this space, upper deck, will be a different coil with its own existence, separate existence. So, separate coils are used. So, double layer winding, we note that the number of coils is equal to the total number of slots present. Okay. Acha, this is one thing. Now, therefore, this coil, what I will do is this, if you look from the top, for each slot, what you will see, I mean in a double layer winding, if you look from the slots, what you will see, I will draw the other coil like this, another coil which will occupy this upper and lower deck like this. So, if you look from the slots, this slot number, you will see one line only, na? The upper conductor you can see, if you see the plan view from the top, this is the length of the coil side. Of course, beneath this one there is another conductor, another coil side of some other coil. So, in a slot I will expect coil sides belonging to two different coils, that is the thing. However, the second one, second conductor, if you look from the top you cannot see. So, what people do is this second conductor, they show it by a dotted line just beside it, close by, and name this as 1 dashed. Understood? That is, whichever coil side will occupy the lower deck, they will be numbered same as the slot number, but with a dash, 1 1 dash or 1 1 prime. Similarly, for 7 there are 2 conductors, and this slot I will show it like this. From the top if you look, you will see okay, there is a conductor at the top, that I should call coil side 7, and besides it I will draw separated by a very small distance, so that I can distinguish and I can understand what is going on. I will write it 7 dashed. So, in this case, therefore, if it is a double layer coil, if this is a double layer, I should name it 1 and 7 dashed. This side is 7 dashed, assuming that it will be used in a double layer mode. Therefore, your coil sides should not be exactly parallel, it will be slightly tilted, so that they can really nicely fit into the slots. The way I described, then these two coil sides should not be exactly parallel, it will be slightly below it. So, if you look any coil of a rotating machine, and they are definitely using double layer winding, and the coil shapes are not exactly in same plane. One coil side is slightly above, indicating that whichever slot it occupies, it will occupy the upper deck, and this one will be below deck, a slight this thing. So, one goes and return to 7 dashed. Therefore, the coil side occupying the upper deck, I will call coil side by the number of the slot. The coil side which will be on the lower deck, I will call once again by this same slot number, but with a prime attached to it, so that I do not make any mistake. Okay. Okay. If that be the case, then we can proceed further. Then I will add another term, that is, suppose I say I with this specification only, S equal to 12, P is equal to number of poles 2, and I want to make a double layer winding, and that is a 3-phase winding, because that is the most popular thing. 3-phase double layer winding I want to make out of these things given to me, S equal to 12, P equal to 12. 3-phase windings are balanced winding. Okay. As you know, this number S equal to 12 tells me that total number of coils is also equal to 12. 3-phase winding you are making, there will be R phase, Y phase, B phase, that is fine, but total number of coils will be 12. Therefore, I can say that number of coils and it is to be a balanced 3 phase winding. Number of coils per phase must be 12 by 3, 4. These are very simple calculations. Okay. Total number of coils 12, R phase must be having 4 coils, Y phase, B phase 2 will be having 4 coils each. Therefore, these are the things I know quickly. And also I tell you that I will make a full pitched coil, use full pitched coil, that is epsilon is 0, of course, epsilon 0, that is the thing. So, then I calculate the value of beta. So, first I calculate slots per pole is 12 by 2, that is 6, that is equivalent to 180 degree electrical. Therefore, beta is equal to 30 degree, 180 by 6, I get that. And then there are 12 slots. First, I will see any slot you can say this is on the rotor, and any slot you can number as 1, but once you fix that, other slot number gets fixed. So, 1, 2, 3, 4, 5, 6, I could call this also 1, 2, 3, it does not matter, we will see, because after all things will be rotating. Okay. So, these are the numbering I have done, and this is the thing. Now, there are 2 poles. Okay. First, let me do it like this without much explanation, we will explain it later, but you see how easy it is. So, there are 2 poles, total number of slots are 12. Therefore, it is expected slots allotted and slot per pole is 6, and under a pole, not pole, there will be total number of 6 slots available, and our common sense tells us that okay, you want to make a balanced 3 phase winding. Therefore, out of this total 6 slots, allot 2 number of slots to R phase, 2 number of slots to Y phase, and 2 number of slots to B phase. That is quite logical. Are you getting? Now, let me start, so that you will understand what I am telling the moment I write it. What I will do, I will say that this is for R phase, whatever I will write below. This is for Y phase and this is for B phase. I will write it like this. And before I do the winding, I want to tell only one point that everyone knows, but I am telling you, you should keep that in mind. It will reduce your hard way of understanding things. One thing is very clear, in whichever way the R windings are accomplished, Y phase winding will be exactly same as that of R phase winding, but it should be displaced in space by 120 degree electrical, that is all. Similarly, B phase will be similar to Y phase winding, which is similar to R phase winding. B phase winding too will be similar to R phase winding, but displaced from R phase winding in space by 240 degrees or displaced in space by 120 degree from Y phase winding. That is how we draw. We are used to draw like this. Okay, this is R phase, this is Y phase, this is B phase in our this thing. So, RYB is the phase sequence. So, axis of R phase coil and Y phase coil, they are equal turns 120 degree apart, that is all. Now, suppose I decide that I will start with R phase. R phase, I start with slot number 1. I put one coil side 1. What will be its return coil side? What is the name of that? In which slot it will return this coil side? 1 plus 6, 7. That is what I told you here. Same example, 1 it must return through 7, but if this 1 is on the upper deck, returning 7 coil side, I will name it as 7 dashed 7 prime, because it will be below. From top you cannot see, you can see the other coil side which will be eventually placed in the upper deck. We will see that. So, this coil I will simply write it is 1 7 dashed. So, I have started my R phase, there are 4 coils will be there, we know before doing anything else. So, 1 coil is put in its place, 1 7 dashed. Now, also I will be using distributed coils for phase and per slot. So, number of slots allotted to each phase per pole will be equal to 6 by, this is slots per pole is 6 by 3, that is 2. Under each pole there are 6 slots available. So, I will be equal to each of the phases, because I am thinking that this will ensure a balanced 3 phase winding. Why unnecessarily you show favor to a particular phase, allotting more slots to that? It should be equal, it looks like. So, I start with 1, give 7 dashed. Then the second coil, because 2 slots are available, suppose, so this 2 it should be 8 dashed. So, R phase 2 coils, and perhaps this is under say south pole or north pole, whatever it is. First 2 slots I have allotted to R phase, and these 2 coils I will call 1 7 dashed and 2 8 dashed. Coil spans are same and each coil is identical, only thing their names will be different. So, 1 7 dashed and 2 8 dashed, R phase is over. Now, this is the starting of R phase. Everything should be, Y phase should be displaced from R phase by 120 degree electrical apart. Now, beta is 30 degree, therefore, 120 degree is equivalent to 4 slots, is not, this number is known. Therefore, it looks like if you have started R phase from slot number 1, Y phase start should be from slot number 1 plus 4 5. So, starting of Y phase should start from 5 and its first coil starts from 5, but coil span is same no matter whether it is R phase, Y phase or B phase, symmetrical 3 phase winding I want to make. Therefore, it will start from 5 to ensure that 120 degree business displaced, and what should be its return? Coil span is same, that is 6. So, 5 plus 6 11, and it is shown in the upper deck without prime. So, it must be shown as 11 dashed. So, this difference should be 6 and this should be this. Similarly, the starting of B phase coil should be after 120 degree from Y phase. Therefore, another 4 you go, that is 5 plus 4, this is 9, and its return should be 9 plus. Therefore, 120 degree I will go from slot number 1. Starting of R phase is from 1, starting of Y phase should be after 120 degree, and 120 degree is equivalent to 4 slots. So, I have added 4 to 1, that is 5 starting, and then its return should be 5 plus 6 11 and 11 dashed because lower deck. So, I think it is okay. Okay. So, this is the thing. Similarly, B phase will start from Y phase after 120 degree, but 120 degree corresponds to 4 slots. Therefore, it should be 5 plus 4 9, and coil span is 6 all the time. So, this is equal to coil span, is the slots per pole, and full pitched coil I am using, no question of short cording the coil. Therefore, it should be 1 4 5 and 9, then add 6 to it, you get 15 dashed. But 15 dashed is nowhere because there are 2 slots. What to do? Because you see, I told you it is a round machine. So, 1 2, if you start from here, reach here 12, then after that once again 1 starts. So, 15 dashed means you subtract from 15 that 12, whatever number you will get, 15 minus 12, that is 3. So, it should be 3 dashed. Got the point? So 1 7 dashed is the first coil of R phase, then first coil of Y phase must start. There should be a special shift of Y phase by 120 degree electrical, and 120 degree electrical is equivalent to 4 slots. So, you add 1 plus 4, you get 5, but coil span, each coils are identical. We are calling it by different names, that is different thing, but coil span is 6 only. So, it will be 5 11 dashed. Similarly, B phase starting should be from 5 plus 4 120 degree, that will be ensured. B will be shifted from Y, and it is 9, and then it should end 9 plus 6 15 15 dashed, but there is no slots marked as 15. What you will have is slot 1, and here it will be 12 slots as you come here, then once again it will be 1 2. So, you have to subtract actually 12 to get this number 3, and then say 3 dashed. Then I want to distribute the coils of Y phase also, because under each pole I will have 2 consecutive coils. That is what I have done for R phase. Then I must do this 5 11 dashed and 5 6 12 dashed. This is what I will do. This one, once I get this, I will say this is 10 and this is 4 dashed. Understood? So, what I am doing is, I am making the windings like this. It is a 2 pole machine. Suppose under 1 pole, let us this writing of south north is for my convenience I am doing, but anyway 2 poles I have allotted to R phase. Then if you have started the winding from slot number 1 for R phase, 1 7 dash, 2 8 dash, 5 11 dash, and so on. Now the question is, but before doing all these things, I knew that total number of coils will be 12 and each phase will have how many coils? Total coils will be 12 because double layer. So, number of coils per phase should be, if you count them at the end, it should be 4. So, look at R phase. Oh, I have got only 2 coils accommodated in those slots. So, another 2 coils still remaining for all these phases, for R phase, Y phase and B phase, where they will be positioned. At least I will give you some indication and I will continue with this. Suppose you see the other pole, that is you have started R phase and under one pole you have allotted 2 slots here. Then the next 2 coils which will be also distributed should start from after 180 degree, because angle between south and north pole pitch is 180 degree. 180 degree is equivalent to 6 slots. So, it should start from 7, that is 1 to 7. How do I get? You have started assuming okay, it is under south pole 1, then the and adjacent to that 2 8 dashed, then next pole whatever you have, that will be separated from this pole by 180 degree, which means 6 slots. Therefore, other 2 coils must begin from 1 plus 6. This how do I get? 1 plus 6, 7. And once you get this number, no looking back. Coil is full pitch, so it should be 13 dashed, but 13 dashed is not there, it should be 1 dashed. Subtract 12 from 13, it will be like this, and allot 2 consecutive coils to R phase, and then it should be 8 2 dashed, like that. Please try to complete this Y and B phase by this logic, and we will continue with this in our next class. Thank you, but these ideas must be very clear. Double layer winding, what it is, total slots, if it is double layer, number of total slots is number of coils, and these calculations do not require any winding to be laid. Okay, 12 coils will be there, as simple as that. Balance 3 phase winding you want to do, at the end you must come up with 4 coils of R phase, with 4 coils of Y phase and 4 coils of B phase. This number 4 is also achieved just like that. But do not forget to calculate beta, what is the slot angle, that is slot pitch. Thank you.